Hi, we are now reaching the third block of Module 5, Impact of Renewables on Electricity Markets. And in this third block, we'll look at how renewables impact electricity markets. By that I mean that we'll look at the very mechanics through the supply curve and the demand curve and their equilibrium. We'll understand why and how renewable generation impact electricity markets. The basic idea can be understood from this kind of plot. This plot represents something we've studied in previous module. We have supply, here represented in blue, and we have the demand, here represented in green. The supply curve may have different type of components related to different market participants with different technology, and you could arguably have different type of ordering, but let's say here wind comes first, which is difficult to argue about. This could be also solar or any type of renewable energy generation with very low marginal cost. Hydro and nuclear would closely follow. Then CHP for combined heat and power, most likely with gas and biomass. Then coal, then oil, and maybe some other form of gas here. So let's look first at the bold supply curve. Let's say that this bold supply curve is for medium wind. So in the case of medium wind, we have the supply curve here that meets the demand at this point. At this point, that means that the cleared amount of energy is for all those on the left here, and that's the overall amount cleared. Then in terms of price, we have to look on this axis, and at the equilibrium point, we get the price that could be used, for instance, for uniform pricing. Now let's move around the wind. If we have less wind here in this supply curve, all the supply curve is shifting here to the left. So that's the supply curve for low wind. And you see that the clearing point has moved. The clearing point has moved such that here, in terms of quantity, we have a lower quantity of energy cleared in the market, and we have a higher price. Now let's increase the amount of wind in the market, and that's going to move the supply curve the other way around to the right, since we have more wind here. When we move this supply curve to the right, the supply curve will meet the demand curve here. And this point, you can see, in terms of energy quantity cleared, it's more to the right. So there's more energy that's being cleared through the market. And in terms of price, we're actually reaching a lower price in the market. So that's the basic mechanism. If you have less or more wind, it's going to impact this equilibrium point and then eventually impact the prices and the energy quantity being cleared. But wait a minute, we're mentioning wind, but that could be solar or any form of renewable energy generation. Is this really the wind generation that is entering here in the supply curve? No, it's not. It's a forecast. We are at the day-ahead market stage. So actually, what affects the prices in the day-ahead markets, the energy quantity cleared, is the forecast we have for renewable power generation, not what we actually produce. And this is something important to remember. Wind power generation acts as a stochastic driver in the market, has an impact on the market clearing, but it's actually the forecast that we have for this renewable power generation that will be the driver for the market prices. Let's look now at the impact of wind by selecting 5 days randomly chosen over December 2011. And in this plot, you see what were the wind power generation pattern for these days. So from midnight to midnight. And here we have the scale of power generation in megawatts. And you may rethink it in terms of energy generation in megawatt hours, since we have hourly market time units in the market. In some places around the world, wind power variability is not that high, or at least you get the same kind of pattern from one day to the next. You may think of places like Crete, Egypt, and some other places like those with thermal effect, where the wind patterns are quite predictable and quite similar from one day to the next. In a place like Denmark, this is what happens. Maybe some days it's very windy and we get a lot of wind power generation. Maybe some other days it's not windy and we don't get a lot of wind power generation. So based on the concept we mentioned before, you can imagine that eventually there are some days where the prices are going to be driven up by the lack of wind power generation. Some other days the prices are going to be driven down by the fact that we have a lot of wind power generation. Remember also, it's not the actual wind power generation that counts, it's the forecast that we have for it. Same goes for solar power or wave energy, if you like. It's just that when we talk about Denmark, we have so much wind power that is the best example to use. Now let's illustrate this impact of renewables by going back to our base case that we studied already in the different modules before with the day-ahead market. In this day-ahead market setup, two participants on the supply side have wind farms. These were Rogue Trading and We Trust in Wind. They were denoted G1 and G2 and had nominal capacity of 350 megawatt and 250 megawatt. So we're going to use these two market participants, play with them, so as to show, based on our day-ahead market setup, what would be the impact of wind power generation, forecast again, on the actual clearing in terms of energy quantity and in terms of prices. For that, we need to assume that for all the others, everything remained the same, since we want to identify only the effect of this wind power generation or renewable power generation in general on the market clearing. And then we can solve the market clearing the same way we did before. When we have this linear programming machinery for the day-ahead market clearing, we can just change the inputs and see somehow what's going to happen. Remember also the supply and demand curves that we had, as well as the example clearing that we discussed. These were the supply curve here in red, with here coming first the wind. And this is the demand curve in black, based on the various offers of the market participant. Based on this setup, we reach a clearing with a system price of 37.5 euro per megawatt hour and a total energy volume cleared of 995 megawatt hour. Now, by changing the amount of wind power generation that G1 and G2 are offering, we're going to see how it's going to impact this equilibrium point, and eventually the price and the quantities being cleared. Let's focus on first daily profile for G1 and G2 offers. So these are the forecasts that they're going to use to offer in the market. You see here the forecast for G1 in red with circles, the forecast for G2 in blue with triangles, and here the total of the two in black with crosses. We will then focus on specific hours with lower and higher wind power generation being predicted, and this would be the results. So at hour 7, there is fairly low wind that enters the market, only 72 megawatt hours, and then at hour 23, we have much more wind with 392 megawatt hour if you take the total of the two. Remember the reference market price we had before, 37.5. Now, if we clear the market with lower wind condition, we see that the price, the clearing price, is of 39 euro, so it's actually higher than the reference clearing we had from before. And the overall quantity cleared, so what is going to be scheduled here on the left of the equilibrium point, it's 965 megawatt hours, so it's less than what we had cleared in the reference case. Now let's look at an hour with much more wind in the system when we clear the market. The price goes down to 32.5 euro per megawatt hour, and then the quantity of energy cleared through the market is 995, which is the same as in the reference case. If we were to look at the whole day, remember the curves we showed before, this is the evolution of the price. So we see that the price goes up and down, and it actually reflects also the pattern we saw in wind power generation, with wind power generation inversely going down when the price goes up and up when the price goes down. And these are the values for the energy cleared in the market in blue with triangle for each and every market time unit of the day. And we can also see the impact of the amount of wind power generation on the energy being cleared overall. We may compare what happens for several days with different wind profiles. We may look at a day where the wind power generation is expected to be average at the beginning, then low, and then picking up again. Some other day, day 2 here, where we start at very low wind power generation, but then it's going up steadily to an average level. Or a third day where we start with very high wind power generation, but then it's going to drop at the end of the day. In terms of prices and energy volume, we can see from this kind of plot with prices in red, energy volume cleared in blue, and then the 3 days represented with circles for day 1, triangles for day 2, and crosses for day 3, we can see there the impact of this wind power generation profiles being predicted on prices and energy volume being cleared. Consistently, we see that there's a relationship. As we predict more wind power generation in the system, the prices are lower, as in this case for the beginning of day 3. And as the wind power generation is getting higher in the system as predicted and impacting the market clearing, we see, for instance, for day 3 towards the end of the day, the prices are getting higher. Same effect on energy cleared as we discussed before. As we have more wind power generation in the system, we have more energy cleared, and as we have less wind power generation in the system, we have less energy cleared. So all in all, these are the important properties to remember. Using the same notations as before, we focus on a given market time unit. We have a market clearing price lambda S. We have PS, the energy volume overall cleared throughout the market. And then for convenience, we're going to denote that this price and this energy quantity are a function of the amount of renewable energy offered in the market, which is derived from forecast, most likely. Eventually, what happens is that in terms of the cleared energy volume, if you clear the market with renewable energy compared to the case of no renewable energy, then the volume cleared with renewable energy is going to be greater or equal to the case where there's no renewable energy. And actually, you can extend that also to quantities of renewable energy. As you have more and more renewable energy, you will always clear more and more energy. Also, in terms of impact on prices, as we have more and more renewable energy in the system through the market, the prices will have a tendency to lower. So in the minimum case, if you clear the market with renewable energy generation, compared to the case there is no renewable energy generation, then the price with renewable energy is at most the price when there was no renewable energy. And we can extend this result by saying that the more and more we clear the market with renewable energy generation, the more the price will have a tendency to decrease. Thank you for listening. Now I would like to invite you to use the self-assessment quiz to check your understanding.